Okay, so let's do in class 2. It says number 1, convert the point from rectangular coordinates to cylindrical coordinates, and the point in xyz is given as 2, 1, minus 2. So let's first find the r. So here's the formula to find the r. Okay, so r is the square root of x squared plus y squared. In our case, x is 2, so it's going to be 2 squared, and y is 1, so plus 1 squared. So it's going to be square root of 5. Okay, let's next find the angle using x equals r cosine theta. So we'll have then cosine theta equals x over r. And also, since we want to change to cylindrical coordinates, we need to write the point P in the form r, theta, and z. So we just found the r, and the z we already have is -2, so we're just missing the theta. So note here also that the x is is 2, the y is 1. That means the angle is going to be in the first quadrant. Therefore, we can just take inverse cosine on both sides. So let me just replace my x and r here, and then we'll take inverse cosine. So we'll have our cosine theta equals 2 over square root of 5 because x is 2 and r is square root of 5. Then taking inverse cosine on both sides, we'll have theta equals inverse cosine 2 over square root of 5. So plugging it out into your calculator, you can check it's roughly equal to 26.57 degrees. Okay, now we have everything to write the point in cylindrical coordinates now, so let's do that. So we'd have then r, which is square root of 5, on up here. Theta we just found is 26.57 degrees, and the z is -2. So this is our point in cylindrical coordinates. Okay, so we're done with question 1. Let's move on now to question 2. So question 2, convert the point from rectangular coordinates to spherical coordinates. Actually, I guess this is the same point from question 1, that's fine. So it's 2, 1, minus 2. So we need to change it to spherical. So let me write out what we need to show. So we need to write in the form rho theta phi. So let's first find the rho, or if you want to call it small p, it's fine, but it's a Greek letter rho. So rho is equal to the square root of x squared plus y squared plus z squared. Let me write it here. So rho then, so square root of x squared plus y squared plus z squared. So it'll be square root of, our x here is 2, so it'll be 2 squared plus y squared, which is 1, plus z squared, which is -2. What should become then square root of 9, which is 3. So our rho value is 3. Okay, let's next find our phi angle. So we're going to be using the cosine of phi equals z over rho. So I have cosine of phi equals z over rho. And then our z value is -2. Our rho we just found is 3. So now we're going to take the inverse cosine on both sides to find phi. So taking inverse cosine, then we have phi equals inverse cosine of -2/3, which you can check is 131.81 degrees. Okay, now we found our phi, we found our rho, we're just left to find our theta now. So let's do that next. So let's first find r, like we did in question 1, it's the same. So it'll be r is equal to the square root of x squared plus y squared, so let's find r. Okay, so r is square root of x squared plus y squared, our x is 2. So it'll be square root of 2 squared plus 1 squared, so it'll be square root of 5 is our r. Now we're going to use the cosine of theta equals x over r like we did for question 1. So cosine will be x over r. In our case, x is 2, r is square root of 5. So let me write that here. So also, we don't need this, but I'm just going to point it out here. The sine of theta would be y over r, which would be 1 over square root of 5. So looking at these two, they're both positive. That means that the angle is in the first quadrant. That means we can either use inverse cosine or inverse sine will give us the right answer. So let's do inverse cosine on both sides to find. Actually, let's do inverse sine on both sides. So we did inverse cosine for question 1. Let's do inverse sine on both sides here. Okay, so taking inverse cosine of both sides here, we'll get theta equals inverse cosine of 1 over square root of 5, which you can check is 26.57 degrees. Okay, now we got everything to write our point in spherical coordinates, so let's do that. So here's our answer, so it's going to be rho, which we found was 3, then theta, which was 26.57, and then our phi, which is 131.81 degrees. Okay, so we're done with this question. Let's move on now to question 3. Okay, let's look at number 3. It says convert the point from spherical coordinates to rectangular coordinates. So we're given the point in the spherical, so it'll be rho, theta, phi. So rho is 2 square root of 3, our theta is negative pi over 4, and our phi is 5 pi over 6. So let's start converting to x, y, z. So let's first use z equals rho cosine phi. Okay, so our z is equal to rho cosine phi. Our rho is 2 square root of 3. Our phi is 5 pi over 6, that'd be cosine 5 pi over 6. And the 5 pi over 6 is in the second quadrant, cosine is negative in second quadrant. The reference angle would be pi over 6, so the cosine of pi over 6 is square root of 3 over 2, so we minus square root of 3 over 2 for cosine 5 pi over 6. 2's cancel, and multiplying the two square roots of 3 makes 3, so it'll be minus 3 is our answer for our z. Okay, let's next find r. So our r is equal to rho sine phi. So r equals rho sine phi. Rho is 2 square root of 3. The phi is 5 pi over 6. So again, 5 pi over 6 is in second quadrant. The sine is positive in second quadrant. The reference angle is pi over 6. Sine of pi over 6 is 1/2. So the 2's cancel, we get square root of 3 for our r. Let's next find x. X is equal to r cosine theta. So we'll have our x equals r cosine theta. So r we just found is square root of 3. The theta angle is negative pi over 4. And the cosine of negative pi over 4, well, negative pi over 4 is in the fourth quadrant, reference angle pi over 4. So it's going to be square root of 2 over 2 since cosine is positive there. So then it'll be square root of 6 over 2 for my x. Let's lastly find y. So y is equal to r sine theta. So y equals r sine theta. So r is square root of 3. Theta is negative pi over 4. So the sine of negative pi over 4, well, the sine is negative in the fourth quadrant. So it's going to be negative square root of 2 over 2. So become then negative square root of 6 over 2. Okay, so now we're ready to write the point in rectangular coordinates. Let me write it here. Okay, so our point in x, y, z. So rectangular coordinates, our x was negative square root of 6 over 2. Our y was negative square root of 6 over 2. And our z was negative 3. So this is our answer here. Okay, we're done with that. Let's go on to question 4 now. Okay, so question 4 says find an equation in rectangular coordinates for the surface represented by the cylindrical equation and then sketch the graph. So here's our equation here. So we need to change this to rectangular coordinates. So let's first get rid of the cosine part here. So let's make an observation. So first observation is that cosine of theta is x over r. So I can replace my cosine of theta over here with x over r. So let's do that. We'll have then r equals 5x over r. Multiply both sides by r. We'll get then r squared equals 5x. Let me write that here. So we'll get then r squared equals 5x. Now I'm going to use the fact that r squared equals x squared plus y squared. So let me note that here. So I'm going to use that r squared equals x squared plus y squared. It's going to replace the r squared here now with x squared plus y squared. So let's do it right here. So we get this then. Now I'm going to subtract 5x on both sides to make it 0 on this side. So let's do that. Okay, so we get then x squared minus 5x plus y squared equals 0. I'm now going to complete the square on this piece here. So let's recall how to complete the square. So here's my completing the square formula down here. So x plus b squared, be expanded. It's x squared plus 2bx plus b squared. Now we're missing the b squared, so let's figure out the b has to be, it's the coefficient in front of the x. So the negative 5 needs to correspond to the 2b. So let me write it over here. So we'll have our 2b then needs to be coefficient in front of the x, so negative 5 dividing by 2. B is negative 5 halves. Now let's figure out what b squared is, so let's square both sides here. So squaring a negative 5 halves, squaring the negative 5 would be 25, squaring 2 would be 4. Now I'm going to add the b squared to both sides here of this top equation, so I'm going to add b squared here and here. So again, I'm going to add the b squared, which is 25 over 4 to both sides. So let's do that, let's write it over here. So doing that, we get this. So it'll be x squared minus 5x plus 25 over 4 plus y squared equals 25 over 4. I'm going to group these first three terms. And by design, they're like those ones. So this will factor as x plus b. Our b value is negative 5 halves. So this is going to factor as x minus 5 halves squared. So let's do that. So we get this tends to be x minus 5 halves squared plus y squared equals 25 over 4. I'm going to replace the 25 over 4 as just, I'm going to write it as 5 over 2 squared. So let me do it. So we have this then. Okay, so this is the equation of a circle. So I'm going to say a few more things, but I'm running out of space here, so I'm going to erase some things and summarize what we have. So summarizing, we have this, so x minus 5 halves squared plus y squared equals 5 halves squared. So this is a circle in the xy plane with center 5 halves 0, because you have to put 5 halves there and 0 for y here, and radius 5 halves. Also, this does not mention z here. That means z is free. I'll explain what that means in a second. So let's look at the graph of this in the xy plane, and then we'll try and do it in 3 dimensions. So let's first graph it in the xy. So graphing in the xy would look like this. So the center is at 5 halves 0, and the radius is also 5 halves, so it would look like this. It'd be 5 over here, it'd be 0 on this side. Now, since the z is free, the z-axis is coming up this way. Is it coming up this way? So think of these circles as repeating going up the z-axis. So just think of stacking these. It's going to create a cylinder. So that's what our graph would look like. So let me graph it over here. So it looks something like this. So it'd be a cylinder. So think of this taking again. It's these circles repeating, going up and going down on the z-axis. So think of taking the circle and fitting it in at the bottom here, and then just repeating those circles all the way up. Is going to make a cylinder. So it's an infinite cylinder. It keeps going up here, and it's going to go down this way also. And this point here would be 5, 0, 0. Okay, and it goes all the way up then. So that would be your graph. Okay, so we're done with this question. Let's leave it there.